Welcome back. All right, now we know the levels, right, of the different routers, what they can be. And then we now know that ISIS is the routing protocol to be. Little poem there. But now we need to understand the NSAP addressing. All right, now this is an IP address gone extremely bad. All right, so I'm going to explain to you, but I'm also, something that's never been said, these are hex numbers. These are hex numbers. I'm going to prove it to you. I'm going to break down the NSAP address to its binary format. So you can understand when somebody says, well, the 8-bit length, the 32-bit length, or 48-bit length, the last 8 bits of the net selector. So we're going to learn the different parts of the address. But when they talk about bits, what are you talking about? Because you can't see it when you look at the address because they're hex numbers. But in the lecture, I'll let you know that. I'm going to show it to you. All right. So very important lecture. Pay attention. See you there. All right, everybody. Welcome back. Now we're going to get into the NSAP address, at least the most common addressing in or common practice in ISIS is what we're going to get into. All right, we need to understand this. So here it says that the ISPs and NSAP, obviously, well, not obviously, all right, but the abbreviation of NSAP is Network Service Access Point. Network Service Access Point. That's what it stands for. Okay. So the NSAP address, the first 8 bits of the address, you can, and keep this in mind, these are hexadecimal numbers. These are hexadecimal numbers. I'm going to prove it to you in the next slide. All right, these are hex numbers. So when we type an NSAP address, the first 8 bits, normally you can choose whatever number you want, but normally 49 means it's private, so we usually put 49. Then the next 16 bits, okay, is considered the area. If you have 16 bits, you should know this by heart, 65,536 areas that you can have, okay? The next 48 bits, they call it here the router's loopback address, is really something that identifies the system, whether it be an IP address, here they're using in this example an IP address, or it could be, you know, router 1111, whatever. It's a combination of hex numbers. So you can put whatever number there, it doesn't affect anything, you're just identifying the system itself. And then the final 8 bits, which is the net selector, okay, is identifying itself. That's what it is. It identifies itself. It's called the net selector, and it identifies itself. Okay, that's what it is. So you got the first 8 bits, right? That's the what's called the AFI, right? And then you have the 16 bits, which is the area, and then the 48 bits, which is just an identification. It could be an IP address, it could be a MAC address, it could be whatever number you want it to be. It's a combination of numbers that's going to identify that system. Okay, it's local, has nothing to do with anything else. All right, and then the last 2 must always be 0 because that is your net selector, your N selector, if you will, and it just identifies a network service user, right? It could be an ES or an IS, meaning an NID or an intermediate system. So it's just identifying itself. All right, that's what that's saying. And they give you an example, right, of the NSAP address. Here's our 49. But this is actually 4 bits here, 4 bits here. And in the next slide, I'm going to show it to you. I break it down for you in binary. All right, so these are 8 bits right here. This is 16 bits, right? 4 times 4 is 16. And you see it is area 1. Here's where the IP address comes in, right? 192. And I just wanted to show you the numbers, 168. So you can see 168, 168. And then they have 1, 1. This being the net selector, because from here, from this 1 in the yellow, okay, all the way to this last 1 in the red, that is the ID, all right? That is the system itself, all right? And that could be an IP address, that could be a MAC address, it could be whatever number you want, basically, okay? But ISP's common practice is using a loopback address apparently, all right? But again, they choose how to create this, all right? They choose, but it depends, because there's only one way to create 192.168, and you'll see in a second. You'll see in a second. And then you have one, and then the end selector is 0. Now this is an interface within the area, all right, in area 1. But let's take a look at that in binary. So remember these right here, all right? So I put this up here again, but check it out. Here you have 49, right? 49. Well, here's the 4, and the 8 is turned on, the 1 is turned on, that's 49. That's how they came up with that 49. Area 1, okay? It's the next 16 bits. Here they are. Next 16 bits. 4 times 4 is 16. Here's 1, area 1. So then we have 192, okay? But it's also 168. But in this next section, everything is broken up into 2 sections of 4. Because if you look, and we go back, if you look at the NSAP address, you see it's after the area is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That means it's 48 bits, right? Because you got 16, 32, 48. Therefore, this is where your 48 bits are at. So when we look at 192.1 is 1, there's the 1, 9, 8 and 1, 2, and then 1 again. Then the next section of 4, we have the 4 and the 2, that makes up 6, the 1 that makes up 8, okay, and then nothing, nothing. Then in the next section of 4, we have 1, okay, and then the next section is 1 as well. And then the next selector is 0. So when they're telling you 48 bits, here are those 48 bits right here, okay? Those are where those 48 bits sit, okay? This is breaking it down into its binary format, showing you the hexadecimal values, right? Because when you look at the NSAP address, I showed you the end selector is just everything is off. All the 8 bits are off. But 8 bits, why is it 8 bits? 1, 2, 3, 4, 1, 2, 3, 4. These are hex numbers. So when you look at the NSAP, it looks pretty simple, right? 49, 001, 1921. You can pick whatever combination of numbers. You're not going to pick anything that goes over F though, because these are hex numbers. These are hex numbers, but you can use whatever number you want. So these are the addresses that ISIS needs, all right, in order to function, right? To know you're in this area or that area, and in order to be able to use all the different CLNS, connectionless network service protocols that it's using, okay? So this is what an NSAP address is. This is the breakdown of that NSAP address in binary, So it's hexadecimal values, which ones are turned on, all right? So when they talk about, oh, the first 8 bits, that's what it means. The next 16 bits, that's what it means. The next 48 bits, that's what it means. And the last 8 bits, that's what it means. Because these are hex numbers that you're working with. I just wanted to show you that so you can understand it. Nobody shows you this, but I'm telling you this. These are hex numbers that you're dealing with. That's why it's so important to understand hex. Not only for IPv6 anymore, but because ISIS, those NSAP addresses are hex numbers. Okay? So what are we going to do next? Now that we know what the NSAP address is and what the level types of the routers are, well, it comes time to configure. But one of the first things we're going to configure is OSPF in a multi-area environment, very simple multi-area environment. And then ISIS, again, a very simple multi-area environment, okay? But using the level types in order to get configuration across our network. Cool? I'll see you in the next one.